So good day to each and everyone. My name is Jainalyn La. So today we will tackle about the arguments and the Euler diagram. So Euler diagrams are visual tools used to analyze arguments and determine their validity. They represent sets and their relationships using circles, making it easier to see if a conclusion logically follows from the premises. So many arguments involve sets whose elements are described using the quantifiers all, some, and none. The mathematician Leonhard Euler used diagrams to determine whether arguments that involved quantifiers were valid or invalid. So in conclusion, the purpose of Euler diagrams is to create a visual representation of each of the aspects in a logical argument so that the conclusion may be clearly evaluated. So how Euler diagrams work? So each circle represents a set, meaning to say a group of things with a shared characteristics. Therefore, the positioning of the circles shows the relationship between the set. And one circle entirely inside another indicates that one set is a subset of the other. So meaning to say that all members of the smaller set are also members of the larger set. And also, overlapping circles shows that the sets share common members. So now, let's use the Euler diagram to determine the validity of an argument. So for example, all college courses are fun. This course is a college course. Therefore, this course is fun. So as you can see, the conclusion is therefore, this course is fun. Try to look at the diagram because the college courses circle is entirely within the fun courses circle. The C represents this course must also be inside the fun courses circle. So now, let's move on how to use Euler diagram in transitive reasoning. So the provided Euler diagram shows concentric circles representing the sets, which is the fried foods, greasy foods, delicious foods, and healthy foods. The innermost circle, which is the fried foods, is entirely contained within the outermost circle, healthy foods. This visually demonstrates that all fried foods are also healthy foods. Therefore, the conclusion or the argument is valid. So always remember that the truth of the conclusion is separate from the argument's validity. So the argument's validity depends on whether the conclusion logically follows the premises. So even if in reality, some fried foods are unhealthy, the argument itself is still valid because the conclusion is a necessary consequence of the premises as stated. So another example, try to look at the picture here. So as you can see, it represents the premises, the three nested circles, which is the innermost circles represents squares, the middle circles represents rhombi, and the outermost circle represents parallelograms. A larger circle encompassing parallelograms represents quadrilaterals. This visually represents the premises. So all squares are rhombi, all rhombi are parallelograms, and all parallelograms are quadrilaterals. So in analyzing the conclusion, all squares are quadrilaterals, so the diagram clearly shows that the square's circle is nested within the quadrilateral's circle. And also, in determining the validity, the diagram demonstrates that if something is a square, it must also be a quadrilateral. Therefore, the argument is valid. Let's try to use Euler diagram to form conclusion. So based on the example here, the problem presents two premises. All MS are NS and no NS are PS. The provided Euler diagram correctly illustrates this. A circle representing MS is entirely inside a circle representing NS, and the NS circle is completely separate from a circle representing PS. So based on this diagram, the valid conclusion is no MS or PS. This is because if all MS are NS and no NS are PS, then it logically follows that no MS can be PS. So lastly, what is cryptarithms? Cryptarithms are mathematical puzzles where letters or symbols represent digits. The goal is to decipher the digits to solve an arithmetic equation like addition, subtraction, multiplication, or division. Each letter represents a unique digit, and the solution must satisfy the given arithmetic operation. They're also sometimes called alphametics or verbal arithmetic. Why is cryptarithms are crucial in Euler diagrams? Cryptarithms are not directly part of the construction of Euler diagrams. It also can serve as valuable tools for illustrating and understanding concepts related to Euler diagrams, particularly those involving logic, sets, and problem solving. They don't fundamentally change Euler diagrams themselves, but their application can enhance the learning and application of Euler diagram principles.